once again, we're going to be filling our minds and our thoughts with concepts in mathematics. Remember, we have budding surgeons and mathematicians and economists and accountants among us, okay? And we need this body of knowledge to help us get where we want to go. Now, over the last couple of lessons, we've been looking at indices, and we'll be using what we did to help us with this lesson. Now, we're still on the topic of algebra. And today, we're going to look at equations that contain indices. And the first kind of equation we're going to look at is when the variable is in the index. When the variable appears as the index. So for example, we can have 2 raised to the x power is equal to 64. So we see the 2 as our base, and the index becomes x. And when we finish, out comes 64. Now we can ask ourselves the same question in this way. What power do we raise the 2 to? That when we multiply the 2 by itself a number of times, out comes 64. How many times do we multiply the 2 so that we can get 64?
5 times.
Matthew says 5 times. You agree with him, Maria?
No.
No. What do you think?
6 times.
6. Now let us check. 2 2s are 4. 4 2s are
8.
8 2s are
16.
16 2s
32.
32 2s.
64.
Now let's put them on the board. 1 2 3 4 5 6. So 2 2s are 4. 4 2s are 8. 8 2s are 16. 16 2s 32. 32 2s 64. So here we have 6 2's being multiplied. So 2 to the 6th power has got to be 64. Now remember, mathematics is versatile. If we don't want to approach the solution in this manner, we look at 64 and we rewrite it. Now let us back up. If we have 4, 4 can be written in another way. 2 to the 2nd power. If we have 25, 25 can be rewritten as 5 to the 2nd power. If we have 27 and we want it rewritten with a base of 3, what will it be? 3 to the 3rd power. Now I have 64. And I want to rewrite 64 in such a way that it must have a base that is on the left-hand side. So it must have a base of 2. So 64 with a base of 2 becomes 64. If I wanted to rewrite it, the base must be 2. What should be my power? 6. So let me come across here. 2 to the x power is equal to 64. 2 to the x is equal to, instead of putting back 64, I'm going to put 2 to the 6th power. Now what do you notice here? That my bases are the same. And as long as my bases are the same, I equate my powers. So now I'd say, therefore, x is equal to 6. And isn't x equal to 6?
Yes.
Yes, x is equal to 6. So 2 raised to the 6th power is equal to 64. Take this example down quickly. this would have been our second example. 5 raised to the x power. So we ask ourselves, what power do we raise 5 to such that when we finish expanding and multiplying, we get 625? So you can either use your fingers quickly as a means, or we can take 625 and rewrite it with a base of 5. What did you get as your answer, Lisa?
4.
4. Lisa has 4. So she's saying that 5 to the 4th power is equal to 625. Now let's check that to see if we're correct. Ready? Let's use our fingers. 5 5s are 25. 25 5s, 125. 125 5s will give us 625. So it's as if we have 1, 2, 3, 4. 5 5s, 25. 25 5s, 125. 125 5s would give us 625. So 5 raised to the 4th power would give us 625. Good. So we go now. Five to the x is equal to 5 to the 4th. And as long as our bases, this condition is satisfied, that the bases are the same on both the left hand and the right hand side, we equate the powers. Therefore, x is equal to 4. Now let's push ourselves and go one step further. In our third example, we have 2 to the 3x is equal to 128. Now, not because you see 3x there, you're going to get all puzzled. It's simple also. The same concept is applied. We have a base on our left-hand side, 2. So we're going to try to rewrite 128 in such a way that it has a base of 2 to some power. So that's the first thing we're going to do. 128 is equal to what? 2 to what power? Find that out quickly. Yes. Yes, Renicia. What did you get?
7.
2 to the 7th power. 2 to the 7th power is the same as 128. Good? So what we're going to do is replace 128 with 2 to the 7th. And remember, if 6 to 4 was 2 to the 6th power, 6 to 4 2s is 128. That's one more. Okay? Good. So we have 2 to the 3x is equal to 2 to the 7th power. Are the bases the same?
Yes.
Yes, that condition has been satisfied. So we're going to equate our powers. So 3x is equal to 7. So we have a simple equation here. Now our 3 is connected to the x by a multiplication sign. We want to group the 3 and the 7 because they are known, our constants. Okay, because our x is what we're aiming to find. Now, because we're multiplying here, as long as this 3 is going to cross this equal sign, we can call it that bridge. It's going to do the inverse of multiplication. And what is the inverse of multiplication, Jonathan?
Division.
Division. X is equal to 7 divided by 3. Okay? Now let us go back. Let us take this 7 divided by 3 and fill it back into x's place here. Let us see if we're going to have 128. So we have 2 to the 3 by x is equal to 128. 2, it's 3. Here we have x as 7/3, which is 7 over 3, and this is 3 over 1. 3 into 3, 1. 3 into 3, 1. What we have remaining is 2 to the 7th power. And that is equal to 128. Go ahead and take the challenge with that one. 4 to the 2x is equal to 256. Yes, Lisa, let me start with you. When you rewrote 256, what base did you use for it? 4. A base of 4. That's a good start. So let me bring 256 down at the bottom here. You use a base of 4. And how many times do we have to multiply 4 by itself to get 256?
4 times.
4 times. So it will be 4 to the 4th power. Good. So we have 4 to the 2x is equal to 4 to the 4th power. Matthew, what did you do after this stage?
I bridge the 2.
You bridged the 2. How did you do that?
I place it on the 4.
What did you place under the 4?
The 2x.
Okay, yeah. Mm-hmm.
And then I brought down the 4.
Okay, so you equated the powers.
Yes.
Good. So after we would have equated the powers, we can do this because this condition has been satisfied. Now we want to find x, not 2x. So we've got to move this 2 from next to x. So the first you have to question yourself. What operation or how is the 2 connected to the x? By the operation of multiplication. So if we want to move it from one side of an equation to another, we have to do the inverse operation. And that would be division. Therefore, x is equal to 4 divided by 2. X is equal to 2. 2 into 2, 1. 2 into 4, 2. So let's replace x up there. 4 to the 2x, 4 to the 2 by 2, and that is equal to 4 to the 4th power. And that is 256. So we know for sure that x has got to be 2. So in this here, we looked at when the variable is in the power or the index. Okay? We saw it when we just had the variable alone. Here we had the variable existing as a product, multiplying by something. Good? Now the main thing here was make sure that bases are the same and understanding how to take a number and rewrite it in another form but having the same value. Good. Now what about if the variable is not in the index? The variable is in the base instead. So here we had 2 to the x power is equal to 60. Here the variable is the power, is in the power. But what about if the variable is not in the power? For example, we have x to the 5th power is equal to 32. So we're taking some number. We don't know the number at the moment. We're going to multiply it by itself 5 times because that is what the 5 is telling us. We're going to take the base and expand it by itself 5 times. And when we're finished multiplying, the product will be 32. So we want to know what is that number. Some number we're going to multiply by itself 5 times. And out will come 32. Does anybody know that number?
2.
Want to tell me, Ria?
2.
Ria says 2. So let us try 2. So we're going to have 1, 2, 3, 4, 5. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So we know that 2 to the 5th power has got to be 32. Now let's explore another approach. We can do that one from inspection. We know the answer. Now, remember, when we were doing the ones when the variable was in the power, we equated the base. So if we had a 2 here, we had 2 to the x is equal to 2 to something power up there. So we equated the bases. In this here, what do you think we're going to equate? When the variable is in the power, we equated the base. When the variable is in the base, what do we equate? The power. So we know that we need to rewrite 32 in such a way. So here we have x to the 5th. We need a base and we need a 5 up here. What must the base be? The base has got to be 2. The base has got to be 2. And as long as the powers are the same, we equate the bases. Therefore, x is equal to 2. Now that's only the second one. The third approach. Let's go again. If we have x to the 5th power, our aim is to find the value of x and not x to the 5th. So what we actually want up here is x to the 1st power. So what must we multiply 5 by to end up with x to the 1st power? What must we multiply that 5 by? What do we multiply 5 by to get 1?
It's the 0 power.
The 0 power? No. What do we multiply 5 by? And when we're done canceling, we get 1. What is that number? Yes, Renita. Very good. 1/5. So we're going to multiply 5 by 1/5 here. 5 into 5, 1. 5 into 5, 1. 1 by 1 is a 1. 1 by 1 is a 1. 1 over 1 is the same as x to the 1st power. And we don't have to put the 1 there. Good. Now, if we do this to the left-hand side, we have got to keep the equation balanced. So we do the very same thing to the right-hand side. So across here, we have 32. And we want 32. We have to raise it to the 1/5 power. And remember, a previous lesson, we did unit fractions. Unit fractions have 1 as their numerator. And they tell us something in particular. For example, we can have 1/2, 1/3, and so on. Those are all units. So if we raise 9 to the 1/2 power, what is this telling us?
The square root.
The square root. So if we have 32 to the 1/5, what is it telling us? The 5th root. So we're going to find now the 5th root of 32. And the 5th root of 32 is what number do I take? Multiply by itself 5 times and out come 32. That's going to be 2. Therefore, x is equal to 2. Questions? Any question, Renita? Matthew? Lisa? Ria? Renicia? Jonathan? You like what you just discovered?
Yes, miss.
Okay, here's your challenge. Good. Now this one is for you. When x is raised to the third power, some number x is raised to the third power, we get 27. Find the value of x. Which one of the approaches did you take?
Means the second one.
The second one. So you tried to equate the powers. Okay? So when you rewrote 27, what did you get?
3 to the third power.
3 to the third power. So x to the third is equal to 3 to the third. And now that the powers are the same, we equate the base. Therefore, x is equal to 3. Now let's check it back. If we have 3 and we raise it to the third power, which is this, out will come 27. Lisa, did you take the same approach?
No, miss.
You did not. Which one of them you took?
Miss, the final.
The final one. Okay. So let's see what Lisa had. Yeah, we started off with x to the third is equal to 27. Yes, Lisa?
Miss, we have you multiply the x with
The power of the x.
by 1/3.
Okay. So x to the third, and the 3 is multiplied by a third because we only want the first power. So when you did that, what did you get when you're finished there?
Cancel to get x to the fourth
You
power.
canceled out there, and you got x to the first power. Go on.
Okay, you times the 27 by 1/3.
You raise the 27 to the 1/3 power.
Find the cube root of 27.
And 1/3 indicates to us that we're finding the cube root of 27. And how do we find the cube root of 27? What do we ask ourselves?
Which number you can multiply by itself to get by itself 3 times to get 27.
Which number do we multiply by itself 3 times to get 27? And that happens to be 3. Therefore, x is equal to 3. So you see, we can, in addition to just having our normal 2 to the 2 power or 10 to the 7 power, we can also incorporate those concepts into equations. Equations where you have variable in the power as well as variable in the base. Now remember, when the variable is in the power, you have to set out to make the bases the same. As long as that condition is fixed, you equate the powers and you solve that equation. When the variable is in the base, you make sure that the powers are the same. And there are several ways in which you can approach the solution of an equation like that. As long as the powers are the same, you simply equate the bases. Okay? It's very simple. You see why you're going to love mathematics?
Yes, miss.
Is mathematics fun?
Yes, miss.
Good. Now let's quickly recap what we did. Lesson 22, Algebra, Equations Containing Indices. In this lesson, we will solve 2 types of equations containing indices. Here are some key points. An equation is a statement of an equality between 2 expressions. It is used in almost all branches of mathematics and in the physical, biological, and social sciences. An equation is said to be satisfied or to be true for certain values of the variables if, when the variables are replaced by these values, the expression on the left side of the equal sign is equal to that on the right side. We will solve two types of equations containing variables. 4 to the x power equals 16 when the variable is in the index. X to the 4th power equals 64 where the variable is the base of the term when the variable is the index type 1. Example 1, if 2 to the x equals 8, find the value of x. Solution, we have to make the bases equal. 2 to the x equals 8. 2 to the x equals 2 to the 3. 2 to the 3 equals 8. Since the bases are the same, the indices must be equal. Hence, x equals 3. Example 2. Given 9 raised to the x power equals 27, find x. Solution, 9 equals 3 by 3, which is equal to 3 squared. 9 to the x can be written as 3 squared raised to the x power, which is equal to 3 to the 2x. 27 equals 3 by 3 by 3, which is equal to 3 cubed. 3 to the 2x equals 3 cubed. 2x equals 3. X is equal to 3 upon 2, where the variable is the base of the term type 2. Example 3. Given x cubed equals 64, find x. Solution using method 1. Check to see if the constant can be expressed as a quantity raised to the same power. 64 equals 4 by 4 by 4 equals 4 cubed. Hence, x to the third equals 4 to the third. Since the powers are the same, the bases must be equal. Hence, x equals 4. Example 4. Given x cubed equals 64, find x. Solution using method 2. Raise both sides of the equation to the same power, but in such a way that the power of the unknown is 1. Solution, hence x to the third raised to the 1/3 equals 64 to the 1/3. X to the 3 upon 1 by 1/3 equals the cube root of 64. X is equal to the cube root of 4 by 4 by 4 by 4 equals to 4. Hence, x is equal to 4. Example 4. Given that 2 to the x equals 16, what is the value of x? A, 1/8. B, quarter. C, 4. D, 8. This question was taken from the National Grade 9 Examination 2006 and the answer is C, 4. Summary. If the bases are the same, the indices must be equal. 2 to the x equals 2 to the third. X is equal to 3. If the powers are the same, the bases must be equal. X to the third equals 4 to the third. X is equal to 4. Problems for today, taken from the book Mathematics for Secondary Schools in Guyana, book 3. It's on page 65 and it's exercise 5D. The questions 2, 6, 10, and 12. Solution for the problems given in the last lesson, page 64, exercise 5C. Express each of the following using the square root sign. Questions 2. A raised to the 3 over 2 power equals to the square root of a cubed. 8. M to the half by x to the 3 over 2 is equal to the square root of mx cubed. Express each of the following with fractional indices. 10. The square root of a cubed equals a to the 3 over 2 power 14. The cube root of 64x cubed y equals 4xy to the 1/3 power. Find the numerical value of 16. 8 to the 1/3 equals the cube root of 2 cubed, which is equal to 2. 20. 64 raised to the negative 1/3 equals 1 upon 64 to the 1/3 equals 1 upon the cube root of 4 cubed equals 1 upon 4.